Hello, I'd like to now provide a supplement, some help for calculating speeds given various information that you might have. We'll need to calculate speeds from time to time in this class, and this is a quick tutorial on how you might do that. So what is speed? Well, you need two pieces of information to find speed. You need to know how far you've traveled. That's the distance. You can see some distances in our solar system, just for comparison. And you need to know how much time it has taken, the duration. You have to have some sort of clock that's measuring how long things have had to last in order for you to get a speed. And so we think of speed as a rate, which is the distance divided by time. We'll use different manipulations of this definition, that speed is distance divided by time, throughout this class to get more information about various situations. Let's start with a sample problem. Imagine you have a car that travels 100 kilometers in 2 hours. This problem is asking, what is the speed in kilometers per hour and in meters per second? So I'm going to use the normal method that I use to solve problems. It's the PACE method. And I'm first going to notice that it's two different questions here. I need to answer the first one first. So the first one is, what is the speed in kilometers per hour? And if you need to have a reminder, the PACE method is for picture, analyze, calculate, evaluate, in that order. So we'll start off with the picture. Now, if I'm going to draw a picture here, I have a car traveling some distance and some time. And it might be useful for me to label the pieces of information I know. That's part of analysis, the analyze step of PACE. So I have two different labels here. I've got the distance, which is 100 kilometers, and I have the time, which is 2 hours. And I'm going to use the letter D for distance, the letter T for time. I also know what the definition of speed is, and we usually use the letter V for speed. It stands for velocity, that speed is distance divided by time, or V is equal to D divided by T. But I have some interesting things I notice here, that D is something I know. It's 100 kilometers. So I can just put that 100 kilometers in the equation. Now notice I'm not going to be doing any calculations yet. This is all still analysis. I'm still analyzing the situation. I can also look at the time, T equals 2 hours, and do the same thing. I can place the time T equals 2 hours in my equation. And now I'm going to rearrange the equation. I'm going to put all the numbers together, and I'm going to put all the units together. I have to make sure I remember what's on the numerator and what's on the denominator of each of these. But if I arrange it properly, I can then see fairly easily what sort of calculation I need to do. And it's only now that I think about that calculation. And that calculation is 100 divided by 2 is 50. And you'll notice that I have units, and I can compare those units to what the question is asking. The question asked for units of kilometers per hour. I have kilometers divided by hours, but remember the S at the end of a unit doesn't change the name of the unit. It's still kilometers per hour or kilometers per hours. So here is my answer, 50 kilometers per hour. And I should evaluate this. Does this make sense? Well, if I travel 100 kilometers in 2 hours, my speed should be something less than 100 kilometers an hour, I think, because it's taking me longer than an hour to get there. So 50 kilometers an hour, sure, that's my evaluation. But what about meters per second? Well, I have much the same picture here, but now I'm going to add some other facts I know. Remember, I have a distance in kilometers and I want a distance in meters. I can get those two things to talk to each other because I know that 1,000 meters is a kilometer. Similarly, I've got a time measured in hours, but I'd like to know what the time measured in seconds is going to be. And I know how many seconds are in an hour. It's 3,600. Well, if you don't believe me, you can try to work that out for yourself. I put those facts listed there in cyan. And now I have the same thing I did before, that the speed is 100 kilometers divided by 2 hours. But I'm going to now add another multiplier. It's something I call a fancy form of the number 1 that's going to allow me to translate between units. I'm going to translate between kilometers and meters by putting kilometers in the denominator and 1,000 meters in the numerator. That is a fraction that's equal to 1. So if I multiply it by the measurement that I have of my speed, it's not going to change the speed. The speed's going to stay the same. But what it will do is it allows me to cancel out kilometers and have meters left behind. This is a clever way of setting up my calculation so that I can figure out exactly what the logic is of the problem. I'm going to do the same thing for seconds and hours, but I'm going to put it together like this with 1 hour in the numerator and 3,600 seconds in the denominator. The hours in the numerator will cancel with the hour in the denominator from my first equation. And that'll leave me with seconds in the denominator. And that's a great thing to have because I need to have a unit of meters per second. So things will start to cancel. First of all, the kilometers cancel on the top and the bottom. And next, the hours cancel on the top and the bottom. And as before, I can rearrange my equation, so I will. I'll put all the numbers together like this. I'm still analyzing. I haven't done any calculations yet. But now it's time for some calculations. So the first thing I'm going to do is get rid of some hundreds. I had 3,600 and I had 100 kilometers, and 100 will cancel with 100. And now I'm going to do another little calculation here. I'm going to take 1,000 and divide it by 72, which is 2 times 36 in the denominator. And now I can put that 1,000 divided by 72 in my calculator, and I get a nice answer like 13.9. And that should be the answer in meters per second. I should evaluate this to make sure that it makes sense. I happen to know that that speed is roughly the speed of an automobile. It seems reasonable. And so that's how I would do this calculation. Now you'll have similar sorts of calculations where you'll have to figure out how far something has traveled in a certain amount of time and calculate those speeds. Next week, we'll use this equation to do some other work as well. But for right now, this is a good starting point. We're going to think about how long it's going to take to travel from one place to another in space. We're going to think about how fast you need to travel to get from point A to point B. We're also going to think carefully about what it would mean to travel the speed of light. And all these things require us to understand some things about speed. So this is why we do problems like this. I hope you enjoyed this little jaunt through our understanding of how speed works. If you do have any questions, feel free to contact me, but hopefully this will help you solve some of the problems on the problem set.